channel Knowledge of Friends. Subscribe to the channel and click the bell icon for the latest update. Today we're gonna start with your physics class 11, that is your class 47, and that is the unit we have, unit 5, laws of motion. We're discussing about the action and reaction pairs, and before that we had covered up many more topics related to it. So we'll go for continuing, and that is action reaction pairs. So in action reaction pairs, before that we had done many more topics related to it. Lastly we had done about forces, where that in the numerical as well, solving problems in mechanics, so you can go for it. In action reaction pairs, here first you have that the force of gravity that we had done in last topic, the numerical one. So for that we'll continue. That the force of the gravity of 20 Newton on the block by the earth, that says an action. Of course, the force gravity on the earth by the block, that is your reaction, equals to the 20 Newton directly upward. That is not shown in the figure that we had discussed. The second, in the block that we discussed, where the force of gravity 270 Newton on the system of the earth, that is your say action. That the force of the gravity of the earth by the system reaction equals to the 270 Newton directed upward. That is not shown in the figure as well. The same way, the another point for the second one, that the force on the floor by the system, that is action. The force on the system by the floor, that is reaction. In addition, for the B1, that the force of the block of the cylinder and the force on the cylinder by the block also constitutes an action reaction pair. In the same way we discuss about it, that the important thing to remember is that the action reaction pair consists of mutual forces which are always equals to the opposite between the two bodies, and the four forces some body which that happens to be equals and opposite, that can never be constitute an action reaction pair, with the force of the gravity on the mass A or B and the normal force on the mass of the floor are not given reaction pairs. These forces happen to be equal and opposite for, like, since the mass is at rest, they are not so for case. And as seen already, the weight of the system is 270 Newton, while the normal force attaches to 67.3 Newton. The practice of drawing free body diagram is of great help in solving the problems in mechanics. It allows you to clearly define your systems and consider all forces on the system due to the objects that are not part of system itself. And a number of exercises in this, as the subsequent chapter, will help you to cultivate this practice as well. Now here for this detail, that Aristotle view that of the force is necessary to keep a body in uniform motion is wrong, and a force is necessary in practice to counter the opposing force of friction. Galileo extrapolate simple observations on motions of body on inclined plane and arrived at the law of inertia. Newton's first law of motion is the same as the referenced arrived in the law of inertia, and where Newton's first law of motion in the same law rephrase. Thus, everybody continues to be in the state of the rest and the uniform motion in a straight line, unless compelled by some external force to act otherwise. In a simple term, that the first law is, if external force on a body is zero, the acceleration is zero. I'll just write it down. If the external force on a body is zero, its acceleration is zero. So where momentum of a body is the product of the mass and the velocity, which is P equals to mv, and that Newton's second law of motion, that the rate of the change of the momentum of a body is proportional to the applied force and takes place in the direction of in which the force acts, and thus F equals to k dp by dt, which is kma. where F is the net external force on a body and A is acceleration. We get the constant of proportionality, which is K equals to 1 in SI unit. Then FdP is your dP, and the SI unit of force is Newton, so 1 Newton equals to 1 kilogram meter second inverse square. You can write it down. 1 Newton equals to 1 kilogram meter second inverse square. The second law is consistent with the first law, where F equals to 0 implies A equals to 0. It is a vector equation, and impulse is a product of the force and the time, which equals changes in the momentum. The notion of the impulse is useful when the large force acts on it in a shorter time to produce a measurable change in the momentum, and since the time of the action of the force is very short, one can presume that there is no appreciable change in the position of the body during the action of the impulsive force. Newton's third law of motion is to every action there is always an equal and opposite reaction. In a simple terms, that the law that can be stated, the forces in nature always occurs between pairs of bodies, and force on a body A by body B is equals to the opposite to the force on a body B by A. Action and the reaction forces are simultaneously forces. This is no cause effect relation between action and reaction. Any of the two mutual forces that can be called action and the other reaction. Action and reaction act on different bodies, and so they cannot be cancelled out. The internal action and the reaction forces between the different parts of the body do, however, sum to 0. Laws of conservation of momentum is that the total momentum of the isolated system of particles is conserved. The law follows from the second law and the third law of motion. Your friction forces opposes impending or actual relative motion between two surfaces in contact. It is the component of the contact force along with the common tangent and the surface in contact, and static force opposes the impending relating motion, which is the kinetic friction of that actual relative motion. And now we'll discuss some of the questions related to it, which is of course been important for you all, which is your additional exercise. So coming from additional exercise, this is the 24 question that I have given you. Other than the solution, so that the position time graph of a body of mass 0.04 kg suggests that the suitable physical content of the motion, what is the time between the consecutive impulse receiving of a body and that is received by the body, what is the magnitude of the impulse. So I just write it on the impulse diagram here that is given for this particular question. This is 2x centimeter. Here you can see. Okay, I think it is visible to you. This is 2, 4, 6, 8, 10, 12, 14, 16. This is of TS. So the question is, a man standing stationary with respect to the horizontal conveyor belt that is accelerating with 1 meter second inverse square, what is the net force on the earth on the man if the coefficient of the static friction between the man's shoes and the belt is 0.2? Up to what acceleration of the belt that can be made continue with the stationary relative to the belt and mass of the man is 65 kg. The another important question we have is a helicopter of a mass 1000 kg rises with a vertical acceleration of 15 meters second inverse square. The crew and the passenger weigh 300 kg. And give the magnitude and the direction of the first is the force on the floor by the crew and the passenger. Second is the action of the rotor of the helicopter on the surrounding air. Third is the force on the helicopter due to the surrounding air. The next question is the stream of water flowing horizontal with a speed of for 15 meters second inverse gushes out in a tube of a cross-sectional area 10 to the power minus 2 meters square and hits a vertical wall nearby. What is the force exerted on the wall and the impact of the water, that assuming it does not rebound? And the question is 10 1 rupee coin and put the top of each other on the table. Each coin has a mass of m. Give the magnitude of the direction and that the force of the 7th coin counted from the bottom due to all the coins on its top. The second is the force on the 7th coin of the 8th coin by the 8th coin, the reaction of the 6th coin on the 7th coin. Another question we have here, which is your 30th question, that is an aircraft execute an horizontal loop at a speed of 720 km per hour with a winch balanced at 15 degree. What is the radius of the loop? 31st question, a train runs along the unbanked circular track and the radius 30 meters at the speed of 54 km per hour. The mass of the train is 10.6 kilogram, and what provides the centripetal force required to the purpose in the engine of the train? What is the angle banking required to prevent the wearing of the rail? Another question is the block of mass 55 kg is raised by the 550 kg man in the two different ways that has been shown. What is the action of the floor by the man in the two cases? If the floor yields a normal force of 700 Newton, which mode should a man adopt to lift the block without the floor yielding? And the question that the monkey of a mass 40 kg climbs on a rope and when stand for a maximum tension of 600 Newton. In which of the following cases the rope breaks, that the monkey climbs up with an acceleration of 6 meters second inverse square and climbs down with an acceleration of 4 meters second inverse square, climbs up with a uniform speed of 5 meters second inverse square, falls down to the rope nearly freely under the gravity, and ignore the mass of the rope. And the question is two bodies A and B masses of masses 5 kg and 10 kg meter contract with each other and the rest on the table against the rigid wall. The coefficient of friction between the bodies and the table is 0.15. A force of 200 Newton is applied horizontally to A. What are the reactions of the partitions and the action reactions between the A and B? What happens when the wall removed, and does the answer to the B that change to the bodies of the motion? Ignore the difference between mu x and mu k. Another question is the 35th question, that is a block of mass 15 kg is placed on a long trolley. A coefficient of static friction between the block and the trolley is 0.18. The trolley accelerates from the rest with 0.5 meters second inverse square for 20 seconds and then moves to the uniform velocity. Discuss the motion of the block as viewed by a stationary observer of the ground and an observer moving with a trolley. 36th question we have here is the rear side of the truck is open on and the box of the 40 kg is placed 5 meters away from that open end, and the coefficient of the friction between the box and the surfaces is 0.15, and on a straight road the truck starts from accelerating with 2 meters second inverse square. At what distance from the starting point does the box fall off the truck? Ignore the size of the box. Then 37th question, it does resolve with a speed of 1/3 revolution per minute, and that has a radius of 15 centimeter. Two coins are placed at 4 centimeter and 15 centimeter away from the center of the record, and that the coefficient of friction between the coins and the record is 0.15. Which of the coin will revolve with the record? 38th question, you may have seen in a circus of motorcyclists driving in a vertical loop inside a death well, a hollow sphere chamber with holes so that the spectacular and a watch from outside explain clearly why the motorcyclist has dropped down. There is an upwards point with no support from below. What is the minimum speed required at the uppermost position to perform a vertical loop in the radius of the chamber is 25 meters. Another question is your 39 question, where a 70 kg man stand in contact with against in a wall and a hollow cylinder drum, and the radius of 3 meter rotating about its vertical axis with 200 revolution per minute. The coefficient of the friction between the wall and his clothing is 0.15. What is the minimum rotational speed of the cylinder to enable the man to remain stuck in the wall without falling when the floor is suddenly removed? 40th one is a thin circular loop of a radius r rotate about the vertical diameter with an angle of frequency, so that the small amount that wire loop remains lowermost point. What is the angle made by the radius vector joining the center of the bead and the vertical down direction? You have to neglect the friction in this. This is the 40th question that I given you other side, so that it will be helpful for you and you can solve by your own if you are able to. That will be helpful for you. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe so that many and maximum people can get the information at once, and you can also enjoy the video as well. Thank you.